In this video, we are going to see another example problem for the model MM1 Infinity FIFO, that is type 1 of queuing theory. We will see the problem. Customers arrive at one-man barber shop according to a Poisson process with mean enter arrival of 12 minutes. Customer spends an average of 10 minutes in the barber's chair. So the following are questions. What is the expected number of customers in the barber shop and in the queue? Next question is, calculate the percentage of time an arrival can walk straight into the barber's chair without having to wait. How much time can customer expect to spend in the barber shop? Management will provide another chair and here another barber when the customer waiting time in the shop exceeds 1.2 hours. How much must the average rate of arrivals increase to warrant a second barber? What is the average time customers spend in the queue? What is the probability that the waiting time in the system is greater than 30 minutes? Calculate the percentage of customers who have to wait prior to getting into the barber's chair. What is the probability that more than 3 customers are in the system? Okay. See here, it is a barber shop problem, very important problem. It is repeatedly asking in the Anna University exams and also in autonomous syllabus. As I said, you have to split the problem into small parts, then only we can get the parameters. Normally, to solve the queuing theory problems, we need lambda, mu and rho. So lambda is what? It is an arrival time, and what is mu? Mu is an service rate. So from this we have to search what is an arrival rate and what is an service rate. So see here, the problem is clear. It is an one-man barber shop. So it is a single server, and they didn't explained about the customers. How many customers are there? Is there any limitation for the customers? There is no limitations for the customers. So it is an infinite capacity of the customers. So first we have to clear that whether the problem is single server and what about the customers. So in this problem, it is a single server problem and the capacity of the customers is infinite. One thing is clear. Next, we have to see the arrival rate. So the mean inter arrival of the customers is 12 minutes. So every 12 minutes one customer is arriving to the barber shop. So it will be lambda. Okay, so lambda can be taken as 1 divided by 12 per minute. Okay, next we will see the service rate. The service rate, here they given customers spend an average of 10 minutes in the barber's chair. So see here, in the barber's chair it will take 10 minutes. Okay, so the average time of service time is 10 minutes. So this can be written as mu. This can be written as mu. It will be 1 divided by 10 per minute. Clear? So next we have, this is the case, we have to take lambda and mu from the problem itself. From the first two lines we can take the lambda value and also the mu value. So next we have to find out rho value. So what is the rho formula of your rho? It is lambda divided by mu. So lambda is 1 divided by 12 and mu is 1 divided by 10. Substitute here, you can get 5 divided by 6. So whenever you are getting a question, you have to first check whether it is a single server or multiple server and the capacity of the customers. Okay. Next you have to find out your lambda, mu and rho. Lambda is nothing but your arrival rate, averagely how many customers are arriving in the shop, and mu is your service rate, how much time it will take to get the service, that is mu. So take the ratio of your lambda and mu, it is your rho. So next, what is the question? Go to your problem and see what is your question. What is the expected number of customers in the shop and in the queue? So what is the expected number of customers in the shop and in the queue? So in the shop, this is a keyword. So in the shop means LS, and in the queue it is LQ. Okay. So what is the formula of your LS? Lambda divided by mu minus lambda, or rho divided by 1 minus rho. Either case you can use. So substitute the values of lambda and mu, you can get the answer as 5. So the expected number of customers in the shop is 5, and the expected number of customers in the queue, okay, in the whole shop, how many customers are there, that will be LS. So in the queue, one is in service, in the line also there are customers. So how many customers are in the queue? It will be LQ. So LQ is LS minus rho. Here we have used your Little's formula. So LS is LS minus rho. What is your LS? LS you found the answer as 5. Substitute that 5 in here, and what is your rho? It is 5 by 6. Substitute those things. Your answer is 4.17. So first question is, we have solved the first question. What is the expected number of customers in the barber shop and in the queue? So second one, calculate the percentage of time an arrival can walk straight into the barber's chair without have to wait. Okay, without waiting this, how many customers are there? Okay, so we have to calculate the percentage. So without have to wait means, what is the meaning of without have to wait? There is no queue. Okay, directly he will enter into the barber's chair. Okay, straightly enter into the barber's chair. So there is no customer. So it is P naught. Okay, P naught is equal to 1 minus rho. The value is 0.1667. So their question is, what is the percentage? So percentage means into 100. So 16% chances are there to directly enter into the barber's chair. Okay. So what is your next question? How much time can customer expected to spend in the barber shop? So they are not telling how much time to take the service. They are asking how much time the customer expected to spend in the barber shop. Okay, so it is WS. WS is nothing but LS divided by lambda. Expected time as customer spend in the shop. He may be in waiting, or we make it an service. So averagely it will take 1 hour to wait in the barber shop. Okay, so next part of your question. So what is your next part of your question? A management will provide another chair and here another barber when the customer waiting time in the shop exceeds 1.5 hours, 1.25 hours, 1.25 hours. Okay, so 1.25 hours means, so already we have checked that how much time a customer can expected to spend in the barber shop. It averagely 1 hour it will take to go to the barber shop and come back. So here, if a person is waiting time is exceeds 1 hour, exceeds 1.25 hours means, what they will do? They will give another chair and another barber, so that the queue rush will be reduced. So here, how much must the average rate of arrivals increase to warrant a second barber? That means how many customers are arriving to this barber shop it will take to get the another barber. Okay, so this will be, so it exceeds 1.25 hours. We have to convert it into for minutes because we are calculating all the problem in minutes. So that's why we are converting into the minutes. So it is into 60, it is 75 minutes. So WS is equal to 1 divided by mu minus lambda greater than 75 minutes. If a person is waiting time is greater than exceeds, that means exists 1.2 hours, it will be 75 minutes means 1 divided by mu minus lambda. So, we have to calculate what is the lambda arrival of your customers. So, it is 1 by mu minus lambda. So, 1 minus mu minus lambda is equal to 1 by 75. We need the value of your lambda. So, that is lambda is equal to mu minus 1 divided by 75. We know that mu is 1 by 10. Service rate is same. So, it is 1 by 10 minus 1 by 75, 13 divided by 150. So, 13 divided by 150 is your lambda value. Hence, to warrant a second barber, the average arrival rate is increased by 1 divided by 300 minutes. Okay. So, next part of your question is fifth one. What is the average time customers spend in the queue? So, normally in the queue, how much time it will take to take the service. So, it is the average time customers spend in the queue. So, WQ is equal to lambda divided by mu minus lambda, it will be 15 minutes. And what is your next one? It will be what is the probability that the waiting time in the system is greater than 30 minutes. So, what is the average waiting time in the system is greater than 30 minutes. So, waiting time is greater than 30 minutes. So, it is P of Ws is greater than 30. The formula is E power minus mu minus lambda into T. We know that mu value, we know that lambda value, here T is equal to 30. Here T is equal to 30, substitute, the answer is 0.6065. Okay. So, next part of your question, seventh question is, what is the seventh question? Calculate the percentage of customers who have to wait prior to getting into the barber chair. What is the question actually here? What is the percentage of a customer who have to wait prior to the into the barber chair? That means what? He is the second person. One is getting the service, the second one very next to the barber's chair, one person is waiting, he is the second person. According to the line, he is the first person to get into the chair. So, what is the percentage of the customers? We have to calculate. Okay. So, your seventh one is P of W is greater than 0, 1 minus P naught. That means he is the second person to get the chair. So, 1 minus P naught is equal to, P naught is nothing but your rho, 1 minus P naught is equal to rho, rho is your 5 by 6. So, percentage means multiply by 100, you can get 83.33. So, what is the last part of your question? What is the probability that more than 3 customers are in the system? So, what is the probability more than the 3 customers are in the system? So, if you calculate P of n is greater than 3, that is rho power k plus 1. K is here 3. So, they are saying the number of customers in the system. So, there are 3 customers, more than 3 customers. So, it is 5 by 6, the whole power 3 plus 1. So, it is 0.4823. Okay. So, while you solving the problem, so you have to be careful in the formulas. So, what is the formula? Whether they are in the system or in the queue or in the shop. That is very, very important. Okay. Next video, we will see some more problems based on this first models.